Hello everyone, welcome to my YouTube channel Easy Programming. I am Naveen Mishra and I'll continue teaching you how to write programs in C and C++ language. In my previous video tutorial, I have discussed compile time polymorphism and how to implement it. I have covered the topics of function overloading and operator overloading there. In this video, I will continue with runtime polymorphism, which include this keyword and virtual function. Before I start this video tutorial, I will like you guys to please subscribe to my channel and share this video with your friends. Okay, let's start with this video tutorial, that is this keyword and virtual function. So this was the diagram of polymorphism, and we have covered all these topics: compile time polymorphism, in which function overloading, operator overloading and constructor overloading has been done. In this video, we'll start with virtual functions or runtime polymorphism. Runtime polymorphism is only implemented using pointers, and in the C language tutorial video, I have explained pointers. I will give you a quick review in this slide and will remind you how to create pointer variable and use it. So this is the program in which I have used a normal variable int a, and I have a int star p pointer variable. Pointer variables are used to store the address of another variable. They can be of any data type such as int, char or float. They are used to store the address of another variables, and they can refer their values using the pointers. So let's say this is my RAM or memory location, and these are the addresses. Okay. As soon as you give any value to your a variable is given some value, let's say 20, and an address is allotted, that is 6487.6228. let's say, suppose this is the address allotted to it. When you do this, after declaring your variable pointer int star p and a, the address of a is copied to p, so this address is copied in p, and using this pointer you can access the values using star operator and operator. And operator points to the address, so this is the address, and star points to the value inside the address, that is 20. So this is the this was the pointers in C language. Now, just like a variable pointer of int, char or float data type, that is basic data type, we can create pointer of user defined data type, classes and objects as well. So just like pointers in C, we can create pointers of class objects. Just we have to use the star operator while the declaration of our object. So this is the example. If you have a class test, then you can create a pointer of test using test star keyword. Now this pointer object can refer to the members of the class in two ways. One is using this dot and star operator. So what you can say is star t1 inside your brackets followed by dot operator and get function, or this arrow operator. So you can say t1 arrow get. So both methods are feasible and can be used to fetch the members of our class using pointer object. This arrow is called the arrow operator and is found by using minus sign followed by the greater than sign in your keyword. Okay, so this is the object pointer. Let's understand it with a program. So this is a program I have written. The name of my class is base, in which I have declared two variable ab, and inside the public function I have used a get function to read the value of a and b, and inside the show function I have displayed these values a and b. The class base ends at the 18th line here, and inside the main function I have created the object and pointer object. So when I do this base a1, that is I have created an object of pointer object of base class. Then object a1 is created, this ab variable as well as get show functions are allotted to a1, and a1 is given some kind of address. When you declare a pointer variable base star p1, a new pointer object is created, and when you write this line p1 is equals to %a1, the address of a1, that is this, is passed to the pointer p1. Now generally when you use the object a1, then you can call the members using a1.get or a1.show. But to call it using pointer, you can use this arrow operator, or you can do like this one as well, star p1.show, and this is your output. So first of all, the 24th line message calling the member using operator, then two numbers because I call the get function, this 10th line and 11th line gets executed, and values 5 and 6 are given, Then I call the show function, this a and b values is shown to you. Then I have called the show function again, but by using different method, and again these values are shown to me. So pointer can also be used to point to the objects of class. Okay, now this pointer. This pointer is generally working in the background whenever you use the variable of the class. So this pointer was generally in use, but now let's study it in detail. So this keyword is used to represent an object that invokes a member function. This point to the object which called the function. For example, a1.get. Now a1 is used to point, a1 is pointed by the this keyword. Okay, so this is a pointer that points to the object for which the function was called. For example, again a1.get, this points to a1. This unique pointer is automatically passed to the member function when it is called. It was already been implemented in the background by the C++ compiler, so we never considered this, but actually the unique pointer was passed to the member function. The pointer this acts as an implicit argument to all the member functions. So implicitly this pointer is passed to the objects. So you can use this or member number. Let's study the program of this pointer first. So this is the program I have written. Now let's say initially you have variable like this x and y, and what you have done is a is equals to x and b is equals to y, and this is the main function. Let me comment this line first, and I have created a base a1 pointer and I call this a1.get function. It will work perfectly, and a1.show function. So what I have done is I am calling this get function and passing two arguments to this get function. These values are received here in x and y and passed to the a and b of the base class. Okay, let's try to run this file. So you see these values are passed to get function, and this get function passes this value to the class variables, and this value is shown to you. Now what if I have the same name argument like this one, a, A, B equals to B. Let's see if it gives you any error. No, it doesn't give you any error, but the problem is you might get confused that which A points to which A and which B points to which B, and you can see the output here as well. The output was not proper, like I was giving values 25 and 65, but some other values are shown to me, garbage. So to overcome this problem, what you can do is you can say this arrow A and then this. Now this says that this a variable is of class variable like that, that is this one, and this b variable belongs to b, and these a and b are the arguments passed to the get function. Now let's compile and run this file, and you see here now it works perfectly. So this pointer was not required generally because you are giving different name to the arguments as compared to the variable names of class, but if the same name is used, then you need this operator to get the values. Okay, so this is the program of this pointer. I hope you guys have understood it. Now let's move on to another topic, that is runtime polymorphism or pointers in inheritance. Now just like creating objects of the class and then creating the pointer object of the class, this can also be implemented in the inheritance. So if we are implementing inheritance and create the pointer of base class, we can use this pointer to pass the reference to base as well as derived class. What I am trying to say here is, if you create a pointer of base class, then this base class can get the reference of base object or get reference of any derived class object. Okay, so using the base class pointer, we can access only those members of the derived class that were inherited from the base class. Now let's say your base have one function get and derived have one function show, and if you are passing the derived class reference to the base class, then you cannot call the show function because it is in the derived. You can only call the overridden methods using pointers. Okay, so simply saying, if a pointer is pointing to the derived class object, then you cannot access the members of the derived class. And while a base class pointer can point to any type of derived object, the reverse does not apply. I will teach you, I will show you how it works in a program. So pointer of derived class cannot point to any other class object. So these are the simple rules. Now let's see and understand this concept. Now this is the program of pointers to derived class. So what I have done here is, let me comment it first, program of pointer to derived class. I have created a base class in which I have used a variable a, and in the get and show functions I have printed the value of a. Then I have created a class derived which inherits the properties of base class. Inside the derived class I have a b variable and get and show for b as well. Now I have created a object of base, I have created a object of derived, and I have created a pointer of base, and I have passed the object reference of base class object to the base class pointer. So pointer of base class refers to the base class object. In such case, when you call get and show function, since pointer and the reference both belong to the base class, so base class get and show will work. And let me run this file up to this run the file up to this point. So these are the values. Now you see here, just a second, let me remove all these extra lines. Okay, let's try to run this. Now pointer is of base class and the reference is of base class object, so the a value is being accessed and being used. Okay, now what if you do this, that is refer to the derived class object. That is, this p1 object gets the reference of d1 object. Now you call this get and show function. Now these get and show functions are both in base class as well as in derived class. In base class as well as in derived class. It will only call the base class values irrespective of the reference passed. So in both cases a value will be used and assessed. Now what if we do not have these functions? Get 1 and show 1. Simply what I am trying to say is, irrespective of the reference passed of derived class object or base class object, the pointers will only call the base class members as they belong to the base class pointer. Okay, so generally when you use this pointer to derived class object, they point to the reference of derived class. Irrespective of the reference passed, they only call the base class members. But what if you want to call the members, this get and show function, based on the type of object referred instead of the type of the pointer? So for this purpose we use virtual functions. So we can implement runtime polymorphism using which the pointer object of base class can access the derived class members. Now we will make it happen that the object pointer of base class accesses the member of derived class. But the members of base and derived class must be of same name and same number of arguments. You have to override your methods, and you can achieve this using virtual keyword or virtual functions. So virtual functions are used to implement runtime polymorphism in C++. If you use the virtual function, the appropriate method definition to execute is selected on the basis of object passed. It is rather than on the basis of the object of pointer base class. Okay, so functions in derived class overrides the virtual function in base class only if their type is same. So you have to make sure their number of arguments, type of arguments, and the name is same in the both classes. When calling a function using pointer of references, the following rules are applied. So if you have a virtual function, then this name confusion is resolved on the basis of type of object passed, and to a non-virtual function it is resolved on the basis of the type of pointer we use. Okay, so these are some rules of the virtual function. So if you are creating a virtual function, you must follow these rules. Now what I can do is I can make sure my these functions are virtual. By doing so, sorry, just a second, I made a mistake here. I have to use the virtual keyword here. Let's try to run this file. Now the first time pointer is of base class, the referred object is of base class, so a values will be executed. But the next time the pointer is of base class but the reference is of derived class object, and because the base class functions are virtual functions, so the derived class function will be executed and not the base class functions. So that is why the B is executing now. Okay, so this is the use of virtual keyword. So virtual keyword makes sure that the function to call is selected on the basis of object passed rather than the basis of base pointer declared. Okay, so while you use the virtual function, you have to follow these rules. First of all, they must be member of some class. So you cannot create a virtual function which is not inside a class. Next, they cannot be static. You cannot use virtual static functions. They are assessed by using object pointers. So using object pointers you can assess them. You cannot assess them directly. A virtual function can be friend of another class. Yes, you can make a virtual friend key function. A virtual function virtual function in base class must be defined even though it may not be used. Now you are using this virtual function, and what if you try to do this, that I know this definition will not be executed, so why should I write this line? Can't we do this? Declare it. The rule states that it is not possible. You have to define the virtual function. Okay, so this is giving you an error. What you should do is you should give some kind of value to it, some kind of reference to it, then it will work. Okay, you see here, so it will work. Okay, so virtual function must be defined, they cannot be declared, and the base class version and derived class version function prototypes must be identical. They must be identical. You see here, identical. Then you can create virtual destructors, but you cannot have virtual constructors as well. While a base class pointer can point to any type of derived object, the reverse is not true. Now what if you do this? You create a reference of derived, pointer of derived, and try to pass the reference of base class object. It will not work. Okay, this is not work. Okay, so this rule states that point. Now if a virtual function is defined in the base class, it not to be necessarily defined in the derived class. What a derived class can do is it can avoid this line, and instead it can create another virtual void get function. So they don't have to define the function, they can pass it to the other classes. Okay, so when a base pointer points to a derived class, increment or decrement it will not make it point to the next object of the derived class. So you cannot do this as well. P1 plus plus, no, it will not work. Okay, it will not point to the next object of the derived class. So these are the virtual functions, and another theoretical topic is pure virtual functions. We have studied it when I was doing this. This is a pure virtual function. A pure virtual function is a do nothing function which does not have its own value, and which have the empty definition. Virtual functions cannot be redeclared, they must be given some values. So this is a pure virtual function, or what you can do is you can do like this one. Both are the pure virtual functions. Both way you can define your pure virtual functions. Okay, so if your virtual function does not have any definition or empty definition, then it is called a pure virtual function. So these are the rules. They only act as a placeholder. They are also called do nothing functions, and these functions are called pure virtual functions. Okay, so they are declared in the base class that has no definition relative to the base class. The compiler requires each derived class to either define the function or declare it. So it can pass it to the other child class or can define it by itself. the derived class. So this is the end of this video tutorial, and I hope you have understood the topic and like this video. I'll see you in the next video. Thank you very much for watching this video. Please do subscribe and share to my channel and like this video. Thank you very much. See you in the next video. Cheers.